Hey guys, welcome to video lecture number 2. This is going to be on average rate of change. We're also going to talk about linear functions in here as well because linear functions and rate of change kind of go hand in hand. So last class we talked about functions, and there's a lot of different functions that we talk about in this class, but one function in particular is really special because it has a constant rate of change, and that is a linear function. So what's really nice is we can say that a linear function has a constant rate of change. Okay, and the formula for a linear function is very simple. We've seen it before, but we're just doing it now with function notation. F of x equals mx plus b. Okay, where this m is our slope or rate of change. Okay, and since it's a linear function, that rate of change is constant. That's why we're able to represent that with a single fixed variable dependent on the function. So every different linear function will have a different slope, but it's that same slope, that same rate of change for the entire function. And then b here, this is our y-intercept, or our starting point. Okay, so this kind of tells us if we are doing a modeling situation, especially if it's something that progresses from 0 on, it is where we start from. Say it's something like the miles we've driven so far on a trip or anything like that. We start at 0, 0, right? After 0 hours, we've driven 0 miles, and then it continues on from there. So this is a really nice simple function. F of x equals mx plus b is our linear form, okay? And we're going to use that to do a lot of things. But let's talk a little bit more about this one. Now, this is should all be reviewed for most of you guys. If it's not, hopefully it's just a refresher. While I'm erasing this, let me just talk about. So the reason I'm doing the board instead of the pull down paper thing is it's hard to see that. I like the view of the chalkboard better on the example video, so this is what I'm going to do. Hopefully I should be getting a larger board in anytime soon. It's going to go right up here, and that'll be for our videos, and we won't have to erase after every little thing I write. So, slope constant rate of change. I'm kind of wanting to emphasize rate of change with slope because it's going to help us later when we talk about average rate of change, kind of related back to this idea of slope that we're already comfortable with. So if we have 2 points, x1 and y1, x2 and y2, our slope, m, is very simply y2 minus y1 over x2 minus x1. It's the change in outputs over the change in inputs. Okay, this is something that, again, shouldn't be something brand new to you guys. It should be fairly straightforward. There's two really important facts here. Okay, the really important thing is that the outputs are on the top and the inputs are on the bottom. Change in output over change in input. And then the other important thing is that the coordinates from one of the points go first, the coordinates from the other point go second. We can't mix those around. What we can do is we can flip these. I could absolutely say this is the same as y1 minus y2 over x1 minus x2. Okay, and the reason why that's the same is very simply, why is this the x1, y1, and x2, y2? If I labeled this point here, whatever it was, as x1, y1, and x2, y2, it's still 2 points that have the same slope between them, and so that would not change. Notice the two things that are the same in both of these. The outputs are on top, the inputs are on bottom. The points, the x and y coordinate from one point go first, and then from the other point go second. So we have here x2 and y2 are first. Here we have x1 and y1 go first. So that's all that really matters. If you can do that, every time you're good. The biggest thing that I see most people mess up on is the inputs and outputs. So make sure that you're very careful. Outputs over inputs. Okay? So for further information on how to find slopes and things like that, go and look at the video on linear functions, on the linear function examples. I'm going to have some more functions. I'm going to show you guys kind of the 4 different situations that you run into when finding a linear function. Either you're given both the slope and the intercept, you're given the slope and a point, you're given the intercept and a point, or you're given 2 points. Okay, so those are the 4 possible ways, the situations that you can be given to find a linear function that we'll deal with in this class. We'll go through 4 examples, one of each of those, find the slopes, do some things with those, and kind of talk about those a little more. Now, one thing I want to talk about is when we're modeling, or when we're dealing with a real-world situation involving linear functions, or really any function. I'm going to talk about how to interpret things from that. Okay, so we're going to start off with a situation. Okay, let's see here. Let's just go with a very simple cost if a can costs, let's say 10 cents per can. Okay, so this is kind of an example where we have both the slope and the y-intercept. Our slope is the rate of change. In other words, so every can that we increase our purchase, it goes up by, or the amount we charge goes up by 10 cents. And our starting value is 0, right? So we can create a really simple, so the amount that we have to pay, depending on the number of cans we get, this is the fun thing with function notation, is we can change up our variables to represent what's happening, right? Rather than just sticking with f's and x's and stuff like that, we can choose variables that represent our situation. So we are dealing with the amount we have to pay depending on the number of cans we buy. So I'm using the variable a and c. So it's just very simply 0.1 c. So the number of cans I buy times the cost of a can, 0.1 or 10 cents, and that's it. Okay. So how do we interpret this rate? I mean, it's already kind of interpreted for us in this problem, and that's kind of why I chose this one, so we knew where we were going, right? We have per can, right? So it's dollars per can. If I were to get 2 points from this, okay, let's say my 2 points are 2, comma, 0.2 and 5, comma, 0.5. Let's find the slope between this, okay? Kind of going into the examples already. So, slope. Now remember, the important thing is outputs first, outputs on top, inputs on bottom. So 0.5 minus 0.2 over 5 minus 2. And this gives us 0.3 divided by 3, which is 0.1. Okay, kind of going off there a little bit. Okay, that's a little better. So now how do we interpret this, right? 0.1, it's like, okay, well, that's not really any help. Okay, I mean, kind of already knew that, right? And if we didn't have this already, we're just given like these 2 values, how do we really know? What we can do is we can use what each input and output represent. The output of this function is the total amount, or the amount of money we pay, so that's in dollars. So our outputs were in top. So then it means the units of this change are in dollars in the numerator, and in the denominator, right, that's the number of cans. So that's cans. So that means that the rate, or the units of our rate of change, of our slope, is dollars per cans. And so by just very simply breaking this out into what do the inputs represent, what do the outputs represent, outputs are on top, inputs on bottom, we can get a really simple kind of unit of our rate of change. In this case, it's dollars per can. Fairly simple. We can also use that to interpret what these mean, right? So what does this mean here? Right? We kind of already know, right? And with linear functions, it's pretty easy. But when we get into more complicated functions, it makes it a little more kind of beneficial to have this simple background. So, well, our inputs represent cans, and our outputs represent price, the amount we pay. So what this says is if I get 2 cans, right? So if the input, which is 2, or cans, is 2. So if the cans I get is 2, then the outputs, which in this case is dollars, is this, right? So then if the cans are 2, the dollars are 0.2. In other words, to put it into a nice grammatical sentence, if I buy 2 cans, I pay 20 cents, or $0.2. Okay. Again, that's probably something that you guys are really bored and kind of scrolling through. But again, this is something that is going to help us out in the long run. When we get to more complicated function with some really weird units or maybe some units of units and things like that, this is just going to make things make a lot more sense. So there's linear functions in a nutshell. Now, only linear functions have a constant rate of change. What that means is no matter what 2 points I pick anywhere on that function, the rate of change will be the same. However, we can calculate rates of change for every other function. The difference is that it is not a constant. And so what we call it is the average rate of change.